Hey guys, so here what we have is a propeller that I use to run my paddle board, motorized paddle board, and this has a 6000 watt motor that spins really fast, and it came with a trigger, so when you are on the water you can just use this to run it. What I did was I replaced that, and it uses this as a PPM receiver. This as a transmitter, this as a receiver, and this connects to the motor controller. So what I ended up doing was I replaced this with an ESP32, which is a microcontroller, and then I wrote an Android app. Let me show you. A simple Android app to be able to just control the speed up and down. So let me connect the ESP32 controller. Okay, now it's connected, and if you can see this, so this, my phone, that's a very powerful motor, but with my phone I'm able to use that. And initially, but the way it was, where is the, here, initially this is the radio receiver, and this was connected to, okay, white goes to white, right. Now if I use this, if I turn this on, can you see it? Yeah. It's a little too responsive, but it works. So, alright, let me turn this off first, because I want to talk about the idea. So, no, not the idea. The idea is simple. I'm going to use this propeller for a different project, and I didn't want to have to keep holding it. So now with the phone I can just set it to whatever speed I want and it will keep running. But the interesting part is I had this idea in the morning yesterday, and it took me about 6 hours to complete the whole thing as it is running right now. And it all worked because I used AI assisted coding. So the app that you see, I gave the requirements. We ran into a lot of issues. This controller uses a PPM protocol, and that is based on a 2000 microsecond pulse. We didn't know that, so we tried to use UART didn't work. Then we tried to figure out, I could have gone into the motor controller and changed it from PPM to UART, but I did that 2 years ago, and now the manufacturer doesn't even have the tool on the website. It's a broken link. So what we ended up doing, when I say we, I and AI, we ended up doing was, instead of changing from PPM to UART, this has different cables for each of those protocols. So instead of using UART, we decided to stick with PPM. But then what I did was, basically I took this receiver, connected to a microcontroller, which then I connected to my PC, and I triggered this, and basically we were sniffing to understand what kind of signal this was sending, and then we basically mimicked the same signal, and now the same signal is being sent to the motor. If I tried to do something like this from scratch before AI, it would have taken me weeks, if not months, to finish it. But because I had access to this tool, it would go to the manufacturer's site. It figured out what the protocol was for the VESC, the electronic speed controller for the BLDC motor, brushless DC motor. It found the drivers, it found pretty much everything that I needed. It takes time. It also made mistake. At some point, it started talking about the increasing the timeout because we were missing data, and I had to correct it, saying if the data was delayed, you would still see it in the buffer in the next read. So a lot of times AI tries to come across as very intelligent, and you have to keep in mind that no matter how impressive it sounds, it's just a model. It's trying to regurgitate whatever it has read over the internet, and it thinks it's smart, but don't be fooled by it. Use your own brain, try to figure out where the problem could be, and then vibe with it. So things like data structure building, if you have 10 things and you suddenly decide you want to put it in reverse, or if you want to put bit masking, or you want to do some changes to the data structure, those are the things you can easily offload to AI. But the thinking, the designing, the architecture of the application should always happen in our head, because AI is not there yet. I mean, I cannot imagine, not just AI, I cannot imagine anyone else who is not aware of these concepts being able to do that, right? If you're trying to hack into a system, whether it is a lawnmower, whether it is a ESC for a propeller for a board, you need the domain knowledge. And as humans, we can continue to provide that domain knowledge, learn and utilize it, but we can use AI to offload that low level grunt work, where you have to, if you need to change thousands of lines in a certain way, just give to it and it will do it in a few seconds, as humans will take a couple days to do that. So very excited. I think this is a very good case to explain how an individual's productivity can go 20, 30, maybe even 50 times if you are able to think and vibe with AI correctly. Ask questions, see the response. Sometimes you correct it, sometimes you think of something else. Productivity of an enterprise is a different scenario altogether, because there, if you don't do it right, not only it can be very low, it can even be negative. If you don't do the enterprise enablement right, your productivity can actually go down, because you can create bottlenecks, you can create backlogs because of excessive production in one part, but not implementing it right in the other. So enterprise efficiency is obviously different, but for an individual, it's a very good example of how you can boost your productivity and get things done very, very quickly. So, alright, thanks for watching.